What if everything you thought you knew about reality, your deepest gut feelings about space, time, how the universe works, what if it turned out to be less about uh, universal truth and more about, well, cultural context?
Yeah, exactly.
We've all been taught space is this flat, empty canvas, right? And time just flows uniformly forward, marching on no matter who's watching.
But are those really innate intuitions? Or maybe ideas we've absorbed without realizing it? That's exactly the kind of fundamental questioning the book we're exploring today really dives into. It challenges these intuitive notions we hold.
So it suggests our understanding of the cosmos isn't just about elegant equations, but it's also deeply shaped by who we are, the societies we live in.
Precisely. The book argues our perception isn't just out there waiting to be found, but it's actively, constructed through our human experience, our societal lens.
That's a pretty big reframe. Okay, so today we're going to try and illuminate the what and maybe the why it matters behind some complex physics ideas.
And alongside that, the powerful social forces that shape how we understand it all.
Right. We'll be weaving together these intricate theories of the universe with some really profound reflections on identity, history, and the very human side of scientific discovery.
It's a journey that really makes you reconsider things.
And just a note, as you reflect on these complex and layered ideas, you might find it helpful to check out Mindful Moments over on our YouTube channel. It offers AI book analysis that's really designed to spark deeper thought and rational reflection.
Good tip. So should we start with the cosmos itself? How modern physics challenges our everyday intuition?
Let's do it. This is where it gets really interesting. Think about the subatomic world, the fundamental bits that make up everything. Quarks, photons, things like that.
Okay.
Now, these particles have a property called spin. You have bosons, the force carriers, like the photon light particles. They have integer spin. A photon has spin 1.
Right. And then there are fermions.
Yeah.
These are the matter building blocks, electrons, quarks. Their spins are always in multiples of a half, like 1/2.
And the crucial thing is this spin isn't like a tiny ball spinning around. It's not intuitive like that.
No, not at all. It's a purely quantum mechanical property. It's fundamental, an axiom that physics students are basically taught to just accept. There's no deeper why given. It just is.
It's just how they are. And speaking of quarks, they build protons and neutrons, right? The cores of atoms.
The stuff we're made of.
Exactly. A proton, 2 up quarks, 1 down quarks. And their charges are fascinating. An up is positive 2/3, a down is negative 1/3.
Do the math.
2/3 plus 2/3 minus 1/3 equals +1. The proton's charge. Simple arithmetic.
And for neutron, 1 up, 2 downs. So 2/3 minus 1/3 minus 1/3 equals 0, neutral charge. It just works out.
It's elegant, isn't it? This deep mathematical order.
Absolutely. And we've even found antiquarks, antihydrogen in labs. The whole mathematical theory, complex as it is, it accurately accounts for all these quark properties.
Even if you don't really know why they have those specific properties.
That's the thing. It's an incredibly accurate description, but maybe not a full explanation of the origin. The why is still elusive.
That's a key point the book makes, right? Science often describes the how with amazing precision, even when the ultimate why is still a mystery.
Precisely. It shows the power of math, but also reminds us there are still fundamental mysteries out there.
Okay, so quarks were already bending our intuition, but get ready, because space-time itself, it isn't straight either.
Our usual picture, the XYZ axis from school, Euclidean geometry.
Yeah, that neat grid.
It's actually quite misleading for the universe on a large scale.
And the irony the book points out is that astronomers assumed a spherical heaven for ages, but science resisted non-Euclidean geometry for the space between things for centuries.
Until Einstein, 1905. He synthesized a lot of earlier work with 2 radical ideas. First, the laws of physics are the same for everyone moving at a constant speed.
So physics works the same whether you're standing still or cruising along steadily.
Exactly. And second, the speed of light is constant for all observers. No matter how fast you're moving towards or away from a light beam, you measure its speed as the same value.
Which leads to some really weird consequences. Length contraction, time dilation.
Explain those a bit.
Okay, imagine you're in a super fast car, near light speed. Someone watching from the ground would see your car as shorter, squished in the direction you're going.
Length contraction.
And they'd also see time passing more slowly for you inside the car. Your clock ticks slower than theirs.
Time dilation. Imperceptible usually, but crucial for fast particles.
Makes you wonder about speeding tickets, right? Could you argue time passed differently?
Hey, probably wouldn't work. But Einstein didn't stop there. General relativity took it further. He used Riemannian geometry to describe curved space-time.
And this completely changes gravity. It's not a force pulling things together anymore.
No, it's an artifact, a consequence of space-time being curved by mass and energy. The famous line is, space-time tells matter how to move.
And matter tells space-time how to curve. It's like a cosmic dance.
A fundamental dynamic interplay.
Okay, so space-time is curved. What about what's in space-time? Here's maybe the most unsettling truth from the book.
Go on.
The everyday stuff, protons, neutrons, electrons, everything the Standard Model describes, it's only about 5% of the universe's total matter-energy content.
Just 5%.
Yeah, which means about 25% is this stuff called dark matter, and a whopping 70% is dark energy.
So in the grand scheme of things, we are the weird ones. We're completely abnormal cosmic stuff.
Crazy. And dark matter, we can't see it, but we know it's there because of gravity.
That's right. Its gravity bends light from distant galaxies' gravitational lensing. It acts like an invisible magnifying glass.
And it's essential for holding galaxies together, right? For forming structures.
Absolutely. Without dark matter's gravitational pull, galaxies as we see them wouldn't have formed or stayed together.
Now, the book makes a point about the name dark matter. It isn't actually dark, like black paint.
No, it's transparent, invisible, like clean glass. Doesn't interact with light at all. The author points out that the term dark is actually pretty problematic, leads to misunderstandings.
Because dark carries other connotations for us.
Exactly. Why did we land on that word? As for what it could be, one candidate is axions, tiny lightweight particles with zero spin. Or maybe a whole family of axion-like particles, ALPs, forming huge halos around galaxies.
Still so much we don't know, which actually leads perfectly into the next major theme of the book. The human element.
Ah, yes. The author's powerful insight. Who you are matters in science.
She identifies as a Black agender woman and argues that perspective allows her, or maybe forces her, to see science differently than the historically dominant group white men.
And it ties into the idea that physics isn't just equations on a blackboard, it's an intensely social thing. Discoveries are rarely one person's lone genius moment.
Like Einstein building on the work of others for special relativity.
Precisely. It's a community effort. And the makeup of that community, who's in it, who's excluded, deeply shapes the science itself. What questions get asked, what metaphors are used.
Which brings up some uncomfortable history, historical exclusions, problematic language.
Definitely. Think about Jocelyn Bell Burnell. She was a PhD student. She observed the first pulsar, proving neutron stars exist. A huge discovery.
But the Nobel Prize went only to her male advisor.
A classic example. And then there's the language itself. The book calls out terms like colored physics, used for quantum chromodynamics, QCD.
That's the theory of the strong force binding quarks.
Yes. The color part is a metaphor for a type of charge quarks carry, but calling it colored physics. Well, given the historical use of colored, referring to black people.
Yeah, that has unavoidable racist connotations. A black physicist in the 60s wouldn't likely have chosen that term.
Unlikely. It shows how cultural context seeks in.
Let's dig into this with melanin as a specific example from the book. It's a natural sunblock, absorbs UV light broadly. Physically interesting stuff.
But our understanding, even what we choose to study about it, is tangled up with history and bias.
How so?
Well, the book points out how bias has been, frankly, consecrated by scientists. Melanin was often ignored, or worse, used to justify mistreating black people.
Like the horrifying example of J. Marion Sims.
Yes, the so-called father of modern gynecology, who performed experimental surgeries on enslaved black women without anesthesia, claiming they didn't feel pain the same way, using supposed biological difference to justify brutality.
And it's not just ancient history. The book mentions modern automated soap dispensers that sometimes don't detect darker skin tones.
A seemingly small thing, but it reveals a failure, maybe an unconscious one, to consider the full range of human variation even in basic technology design.
Wow. And beyond just skin color, melanin itself has fascinating underexplored properties.
Absolutely. Its electrical properties are flexible. Sometimes it conducts electricity, sometimes it insulates, depending on things like water content. The author argues passionately that black thoughts, like black lives, matter.
Meaning, black scientists should be leading research into areas like this.
Yes, because diverse perspectives can unlock new scientific avenues that might otherwise be missed or ignored. It's about better science, ultimately.
But getting into those positions is a struggle. The book talks about the burden on black women in physics, often having to carve out their own sense of belonging.
Where no black woman scientist has gone before, as the author puts it, it's immense emotional labor. often invisible and unrewarded.
And it connects to that awful saying, you have to be twice as good to get half as far.
Which itself is rooted in this damaging myth of inherent white male superiority in science.
Yeah.
It fuels the idea that prioritizing diversity somehow means lowering standards, sacrificing excellence.
When in reality, diversity often drives excellence by bringing different viewpoints and approaches.
Exactly. And then there's the extra work of supporting marginalized students, mentoring, advocacy, vital work, but often not counted as real scientific contribution when it comes to career advancement.
It all paints a picture of science as a complex social and, crucially, ethical enterprise.
Which the Mauna Kea controversy really highlights. The conflict over building giant telescopes on land sacred to Native Hawaiians.
The scientific community pushing forward, disregarding the spiritual and cultural harm being done.
It forced the author into a personal crisis, realizing science isn't pure. It's tied to the military adaptive optics for spy satellites. Helps astronomy too, but also to colonialism, to capitalism.
That pursuit of knowledge clashing directly with respect for indigenous culture and sovereignty. A stark contrast.
It makes you ask fundamental questions about science's impact.
So, connecting this all together, the book argues science is both mathematical and deeply human, deeply social. How do we move forward? How do we reimagine physics?
The author suggests Black feminist thought offers a valuable framework. It emphasizes creating communities that are in good relations with each other, fostering well-being within the scientific process.
Moving beyond just identifying problems to actually building better structures. She mentions mutual aid.
Yes, as a non-hierarchical way to solve problems. Not just socially, but potentially rethinking how scientific collaborations work too, making them more equitable, maybe more creative.
It's about changing the purpose of science, isn't it?
Perhaps reframing it. Maybe its purpose can also be to nourish the soul, to cultivate wonder, allow for genuine curiosity, rather than just serving state or corporate interests or perpetuating harm.
The book says freedom looks like making room for Black curiosity.
And for the curiosity of all marginalized people, allowing them to explore science without fear, without discrimination, creating genuinely inclusive spaces.
So wrapping up, it seems understanding the universe isn't just about the physics equations. It's also about understanding the humans doing the physics, the history, the social context.
Who does science and how it's done really matters. It shapes what we find and how we see it.
We really hope exploring the book today has given you some, unexpected facts and maybe some new ways of looking at the world.
Yeah, and if you want to keep digging into these kinds of ideas, remember to check out Mindful Moments on our YouTube channel and, of course, our podcasts for more analyses that get you thinking.
Yes, please do. And subscribe to the show if you haven't already for more explorations like this one. Share it with someone you think would appreciate a different perspective on science and the universe.
And if you're interested in reading the book we've been discussing, you can find a purchase link right there in the description.
So the challenge for you is, what does all this mean for you personally? How does your own viewpoint shape how you see the cosmos and our place in it?
And maybe one final thought to leave you with. If science really is this human social enterprise, what hidden figures, what unheard perspectives are still out there waiting to completely transform our understanding if we only make the space for them?